We looked at how to be able to measure pH. We looked at the equation that you would have to use and kind of what those pH numbers mean. Well, how do you measure that pH once you get into the lab? So that's what this section is going to help you with. So how do you actually measure the pH when you're in the lab? Well, probably the most common way, the quickest, the easiest, kind of a rough way to measure pH is to use what's called an indicator dye. We have two indicator dyes that we use most commonly. These are not by any means the only two. These are the two that we're most likely to use. The first is litmus. I know, I wrote it second. Litmus is on there. Now, litmus can tell you if you have an acid or if you have a base. Litmus in an acid turns red, and in a base it turns blue. Now occasionally you have to get special litmus paper, so you use blue litmus paper, see if it turns red, and red litmus paper, see if it... I use what's called neutral litmus paper, so you would just dunk that in or add a drop of your substance to the paper, and it would change either a reddish pinkish color or it would change a bluish color if you had an acid or a base. Phenolphthalein is another common one. Now phenolphthalein is only going to tell us if we have a base. It cannot distinguish between acids and neutral. So it's only good for bases, and we're going to go over the colors on the next slide. pH paper has a whole bunch of different indicator dyes that have been put together, and then they've been put on a piece of paper. So when you add your solution to that paper, so you add a little drop, it'll change the paper to a variety of colors from red to yellow, green, blue, purple. Based on the color it changes, there's a guide that will tell you what the approximate pH is. Finally, we have a pH meter. A pH meter is very accurate. You can easily get 0.01 pH units instead of, oh yeah, it's around a 1, it's around a 10. Now we can get a very accurate representation of what that pH actually is. But pH meters can sometimes be a little more tricky to use. You have to keep them in a solution, a storage solution. The electrodes are very fragile, meaning that you have to be very careful or they break. And you will also have to calibrate the pH meters. But that is available if you're doing some work that needs to have very accurate pH numbers. So here are a few of the things that we had talked about. In the top left is a pH meter. Notice this one happens to be testing yogurt. It has a pH of 4.29, so we can get out easily to the hundredths of a pH unit. But again, that one has to be calibrated and it's pretty fragile. On the bottom is kind of a fun one. So occasionally what I'll do with my classes is I'll have them try to find a natural indicator. On the bottom, they've used the extract of red cabbage. So the cabbage that you get in your salads that you usually don't eat, you can take that cabbage and you can put it in like isopropyl alcohol and extract the dye out of it. That dye is pH sensitive. So down the bottom, you'll actually see it goes from a red through a purple, green, and yellow color, depending on what pH level you're at. That one is fun to play with. It's fun to see that. Cabbage is not the only thing that this will happen with. There's some beets, blueberries, cherries, red cabbage. There's some special flowers that, depending on the pH of the soil that they're planted in, they'll actually be different colors also. So kind of fun to play with on that one. On the right-hand side, we have universal test strips or pH paper. There's a guide that's printed on the roll that has all the different colors and the approximate pH they represent. So red starts at a 1, and this one goes from 1 to 10. You can buy different test papers that test different ranges. So this one, it looks like it turned blue. So it's normally that kind of it's like a yellowish orangish color. And then you put it into your solution and it'll change. So this one changed pretty blue. I would say it's a 10. So you just look at the color, match it, and that's how you would get your approximate pH. Now this one has the litmus and phenolphthalein. Your litmus is on the far left. The acid is on top. So litmus paper, the one I use, starts out as kind of this pinkish purplish color, and so if you put it in water it just looks like it got wet, but if you put it in an acid it turns this pinkish red color, and that's supposed to be represented on top. On bottom they've placed the test strip into your solution and it's turned blue. Now if you want to get really technical, if you have, by placing the litmus paper into your solution, you've slightly contaminated your solution. For us, it doesn't matter, but there are certain fields where they will tell you to place a stirring rod into your solution and then touch that to your paper. Just a little technical hands-on thing depending on what field you go into. On the right is an example of a titration using phenolphthalein as an indicator. Now in this particular titration, they've started with acid. I know that because it's clear at the bottom. Acid with phenolphthalein has no color in it. In the burette, that's the thing on top, they've added a base, probably sodium hydroxide. And so as they add that base, it starts to neutralize the acid. Once it's completely neutralized one portion of the acid, it'll turn to a base as you add additional drops. So you can see little bits of color that have come into that solution. But if you swirl it, overall there's more acid than base, more hydronium than hydroxide in that solution, and so we'll go colorless again. Once you've completely neutralized the entire solution, if you add any more, it turns the entire solution to a base, and so the phenolphthalein changes colors. And so clear or colorless in an acid and neutral, and in a base it turns to fuchsia. Fuchsia is this pinkish purplish color. Now ideally we want it to be just as light as possible. But if you accidentally add a drop or two extra your sodium hydroxide, it doesn't take much, it turns to this bright, vivid fuchsia color. It is the color of my 8th grade graduation dress. Yes, here I am in 8th grade. Now, be kind. 8th grade was way back in 1990. Big hair was very popular. Big glasses were very popular. I actually made that dress. I sewed it myself. My mom thought it was absolutely scandalous because it was very fitting on top and it was too short. And so then I had to make the jacket to go over it. Oh, man. Anyway, the reason I show this, the color of phenolphthalein is the color of that dress, that fuchsia color in a base. So one little end of lecture question for you. The litmus test determines if a substance, it should be if, not is, if a substance is an acid or a base, true or false? Well, a litmus will turn red in an acid and blue in a base. So yes, it can determine if you have an acid or a base. Phenolphthalein can only be used to verify you do have a base.